Yo, what's up, guys? Welcome back to another video. Today we're gonna be talking about mean value theorem, also known as MVT. And you might be wondering, to yourself that this sounds really familiar to the intermediate value theorem. However, it's very different. So essentially, what mean value theorem is, and first off, let me just draw a graph. Say we had like a function like this. Supposedly, and this is the theorem, if this function, if f of x is continuous on the interval of a to b and differentiable on that same interval a to b, then there must be a value such that f of c is equal to the slope from b to a. So this is essentially what I mean. Let's say this is a slope, right? If it's continuous and differentiable, then there has to be a point at least where that specific slope has to equal that point, which is parallel to it. That's essentially what mean value theorem is. And so we're going to go through some examples, and essentially I'm going to see if I can make it to the graph, because mostly you just be working algebraically. But essentially this is what we do. So first off, let's say you had, I don't know, x squared. F of x is equal to x squared. And let's say you had the interval of 1 to 3. We know that x squared is a polynomial. So it's continuous on all real numbers. And is differentiable on all real numbers. So we know that the domain is good. We know that. So let's see how it works. So first off, let's just find f of b minus f of a. Our b in this case will be 3, and our a in this case will be 1. So we just do f of 3 minus f of 1 all over 3 minus 1. F of 3 is 9 minus 1 all over 2 is equal to 4. So since we have our f of b minus f of a all over b minus a, what we can do is we can set this up to the derivative of x squared. So we know, using the power rule, f prime of x is equal to 2x, because power rule, so it'd just be 2x. From here, what you can do is you just set these up equal to each other. So you do 2x is equal to 4. Then from here, you realize that since x is equal to 2, that means 2 is the place where the slope is going to be 4. And it makes sense, because you have f of b minus f of a, which is b minus a. And we know that this is slope at a tangent. So we know that this is a slope, and x equals 2 is going to have an area where the slope is 4. So that's how we can find it, which is really cool. So then let's say we had 1 over x. Actually, not 1 over x. Let's say we had natural log of x equal to our f of x on the domain of 1 to 4. Let's find a value that fits the mean value theorem. So from here, we do f of b, which is 4. So we do f of 4 minus f of 1 all over 4 minus 1. From here, f of 4 is just natural log of 4 minus natural log of 1 all over 4 minus 1. Well, we know that natural log of 4 minus natural log of 1. Natural log of 1 is just 0. And if you want to see why, comment down below. I don't want to prove it right now. But essentially, we have natural log of 4 over 3, which is our f of b minus f of a all over b minus a. So now we just have to find the derivative of f of x. So essentially the derivative of natural log of x is just equal to 1 over x. And I have no idea how to prove it. Because I can prove like a bunch of other ones, but I don't know why. It makes sense to an extent if you don't know how to prove it, but it's like, I don't, I don't really know for real. But anyway, you just set up the derivative of natural log of x. So it'll be 1 over x is equal to natural log of 4 over 3. From here to find x, there's two ways to find this. First, you can do it the long way, multiply by x, multiply by 3. So then you'll get 3 is equal to natural log of 4 over, just times x. Then you can just divide by natural log of 4 to get your x, or you can just flip it. But essentially, we do know that there's at least one point where the slope and the tangent slope at that point and the derivative are going to be equal, which is x is equal to 3 over natural log of 4. So let's do another one. Let's say we had e to the x. I'm just making these up. And from the domain of 0 to 5. From here, what we do is we just set it up again. F of 5 minus f of 0 all over 5. Because we can just subtract the 0 because anything minus 0 is just the same. So then from here, f of 5 is e to the 5 minus e to the 0, which is just 1, all over 5. So from here, we just set it up equal to the derivative of e to the x. So if you already ahead, you would know that e to the x, the derivative is just e to the x. Because essentially the graph is so weird that whenever you have the derivative of e to the x, the derivative is just the same thing. So that's kind of one of the special functions. From here, you solve like normal. Actually, don't do that. All you have to do is just put a natural log here. So from here, natural log of e to the 5 minus 1 all over 5 is equal to x. And that'll be your conclusion for the mean value theorem. So essentially, this is just a little lesson to just get into mean value theorem. Doesn't seem that hard, and it really isn't. However, if I did make a mistake, please tell me. I'm not perfect. So thank you for watching. Please like, share, subscribe. This has been mean value theorem, and goodbye.